Hello everyone. Today, we will learn about LED dot matrix displays together. LED dot matrix is a display technology that forms a matrix by arranging LEDs, light-emitting diodes, to display text, graphics, and animations. The basic structure of an LED dot matrix display consists of multiple LEDs arranged in rows and columns, forming a rectangular grid. Each LED at the intersection can be individually controlled to turn on or off, thus displaying different patterns or text across the entire matrix. Next, we will mainly focus on the following topics. 1. Definition of LED dot matrix displays. The LED dot matrix display is composed of LED dot matrices, displaying text, pictures, animations, videos, etc., through the lighting and extinguishing of red or green lamp beads. It is a display device with all components modularized, usually consisting of a display module, control system, and power supply system. The production of LED dot matrix displays is simple, and the installation is convenient, making them widely used in various public places, such as bus station report devices, advertising screens, and bulletin boards. 2. Principle of LED dot matrix displays. Take a simple 8 by 8 dot matrix as an example. It consists of 64 light-emitting diodes, each placed at the intersection of a row and a column line. When a specific row is set to high level, 1, and a specific column is set to low level, 0, the corresponding diode lights up. For example, to light up the first dot, pin 9 is connected to high level and pin 13 to low level, illuminating the first dot. To light up the first row, pin 9 must be connected to high level, while pins 13, 3, 4, 10, 6, 11, 15, 16 are connected to low level, illuminating the first row. To light up the first column, pin 13 is connected to low level, while pins 9, 14, 8, 12, 1, 7, 2, 5 are connected to high level, illuminating the first column. Typically, we use a 16 by 16 dot matrix Song typeface font library to display Chinese characters on dot matrix displays. The so-called 16 by 16 refers to the fact that each Chinese character is displayed within a region of 16 dots in both vertical and horizontal directions. That means 4 8 by 8 dot matrices are combined to form a 16 by 16 dot matrix. For example, to display the character ni, yu, the corresponding dots need to be illuminated. Since the dot matrix is active low on column lines and active high on row lines, to display the character ni, yu, its bit code information must be inverted, that is, all columns, pins 13 to 16, should send 1111101110111111 0xF7, 0x7F. Then, for the first row, pin 9, a signal of 1 is sent, followed by 0 for the first row. Next, the data for the second row to be displayed, pins 13 to 16, should send 11111011111111 0xF7, 0x7F. And for the second row, pin 14, a signal of 1 is sent. Similarly, as long as the time interval between each row's data display is short enough, utilizing the persistence of vision effect, after sending data 16 times to scan all 16 rows, the character ni, yu will be visible. The second method of data transmission involves sending the character pattern signals to the row lines and then scanning the column lines, which follows the same principle. Again, using the character ni, yu as an example, for the 16 rows, pins 9, 14, 8, 12, 1, 7, 2, 5, send 16 zeros, 0x00, 0x00. While for the first column, pin 13, send a 0. Similarly, scan the second column. After sending data 16 times to the row lines and scanning the column lines 16 times, the character ni, yu will be displayed. 3. Driving of LED dot matrix displays. From the internal structure of LED dot matrix displays, it is advisable to operate the devices using a dynamic scanning driving method. Since most LED chips are of high type, the driving current for individual LEDs in a certain row or column can utilize narrow pulses, yet their average current should be limited to within 20 milliamperes. The forward voltage drop of individual LEDs in most dot matrix displays is approximately 2 volts, but for larger bright spots like Phi10 dot matrix displays, the forward voltage drop of individual LED is about 6 volts. Large screen display systems are generally composed of multiple small modules made up of LED dot matrices, assembled in a building block manner. Each small module has its own independent control system, and once combined, they only require a master controller to manage the commands and data for each module. This method is simple and features easy expansion and maintenance. In LED dot matrix display systems, there are 2 display methods for each module: static and dynamic display. Static display is simple in principle and convenient to control, but it involves complex hardware wiring. In practical applications, dynamic display is generally used. Dynamic display works by scanning, driven by narrow pulses with a large peak value. It sequentially and continuously selects each row of the display from top to bottom, while simultaneously sending pulse signals representing graphic or text information to each column. By repeatedly cycling through this operation, various graphics or text information can be displayed. 4. Classifications of LED dot matrix displays. LED dot matrix displays are classified by color into monochrome, bicolor, and full color, capable of displaying colors such as red, yellow, green, and orange. They are also categorized by pixel size into various types like 4x4, 4x8, 5x7, 5x8, 8x8, 16x16, 24x24, 40x40, and more. Based on the number of pixels, they are divided into single primary color, dual primary color, and triple primary color. The color of the text, images, and other content displayed varies with the color of the pixels. Monochrome dot matrix can only display fixed colors such as red, green, and yellow, while bicolor and tricolor dot matrices can display a wider range of colors through combinations of different colors. This is determined by the combination of different color LED slit within the pixels. For example, when red and green are both lit, yellow can be displayed. If the lighting duration of the diodes is controlled in a pulsed manner, it is possible to achieve 256 levels of grayscale or higher, enabling true color display. 5. Characteristics of LED dot matrix displays. 1. High brightness. Compared to discrete surface-mounted devices like 0603 or 0805, LEDs can reflect more luminous flux. 2. Achieve ultra-high density. Up to 62.5 dots per square meter indoors. 3. Good color mixing. Utilizing the microprocessing of the light-emitting devices and the wave-particle duality of light, red, pure green, and blue particles are thoroughly mixed together. 4. Good environmental performance. Resistant to humidity, temperature changes, and corrosion. 5. Excellent anti-static performance. The manufacturing environment has strict standards, and the product structure is designed with insulation in mind. 6. Large viewing angle, 140 degrees, horizontal direction. 7. High transparency. The new generation of dot matrix technology, with its high purity performance and epoxy resin material with nearly 100% light transmittance, achieves an almost perfect transparency rate. Today, we have learned the basics of LED dot matrix displays, mastered their matrix structure and the principles of illumination control, understood dynamic scanning driving and row column level control methods, and learned how to protect LEDs by limiting current and voltage. This knowledge lays a solid foundation for future applications in fields such as LED display technology, advertising design, and information dissemination systems. To better consolidate and deepen your understanding and mastery of the knowledge from this lesson, please complete the following exercises after class. See you in the next lesson.